Good afternoon, everyone. My name is Peter, and I am a lecturer in the Department of Chemical Engineering, and I teach a lot in first year. So it's quite exciting to already be in touch with quite a few of you before we actually see you in the classroom next year at UCT. I'm not here alone. There's some people in the background as well. So there is a Q&A option where you can ask questions or type questions, and Bridget, who is our undergraduate administrator, will keep an eye on those questions, and when we get to the end of the presentation, we'll answer as much as we can. The ones we can't get to, we'll type up answers so that we can share that with you afterwards. So what I'll do in this presentation is sort of briefly take you through again what chemical engineering is, and then a bit more specific about how we teach chemical engineering at UCT. So we'll jump straight in. And so for those who are not familiar yet with what it really is about or unsure, so chemical engineering involves everything where we change raw materials into useful products. So what that means is, if you can think of anything where you take a material from one form to another form, and that involves chemical engineering. So it's mining minerals and then turning that into metals like copper wire, telephones, making soap, making shampoo, making food, taking cotton all the way from the field into actual shirts, the petrol we put in our cars, everything that's in plastic, that all goes through a process, and those processes are typically designed and run by chemical engineers. And so what's important, so what do we focus on when we teach chemical engineering? It's firstly you need to know the chemistry, the biochemistry, the physics with what you're working with. You can't handle things if you don't know what you're dealing with, so you need to know that. And then you need to know something what's called unit operations. And I'll get to that in a minute, what that is. But so chemical engineering, or all those processes, is a combination of understanding the science behind it and then doing unit operations with them. And in addition to that, we need to do all of that in a safe, sustainable, and cost-effective way. We need to look after the environment. We need to make sure that plants don't explode, and we need to make sure that the process is economically viable, so that we can pay people salaries at the end of the day. But as I said, to give you some more background around these unit operations, because those are really core to what a chemical engineer actually is and does on a day-to-day basis. So a unit operation is any generic process stage you can think of. So there's some examples here. So solids, you need to know. We can only handle that typically with conveyor belts. Liquids, like here, this is a water treatment plant. Liquids we need to pump. We can't run that on a belt like this. Then sometimes we need to mix stuff. So this is how you make chocolate. We want our chocolate to be nice and smooth. So that needs to be mixed properly so that there's no bits and pieces left in there. If we need to do chemical reactions, so if we want to make soaps and petrol, we need big reactors to do that in. So that's also unit operation. Then other things are when we need to dry stuff, when we need to filter stuff, when we need to separate, for example, solid and liquid. So if you think about the water treatment plant, we don't want stones and rocks and leaves in our drinking water, so we need to separate those things out. We can do extrusions, which is pushing stuff in a certain shape. So all of these things, and there's many more, are unit operations. And so what a chemical engineer does is put those together like a puzzle or little Lego blocks to actually make a process. And I'll show you some examples. So one is for example, how we go from our rainwater all the way to water that we can drink from our taps. So if there's impurities in there that we want to take out, we put stuff in that's called coagulants, so that those impurities become bigger pieces that we can then let sink in a tank and then eventually filter out. And then we need to make sure that there's no bacteria or viruses left in the water. And then we also need to make sure that the pH is right. We then store it, and then it goes to your tap at home. And so each of these steps, so we add this, we mix this, we let it sink out, we add this, we pump it along, we filter. So each of those steps, that's a unit operation. This is an example of how to make washing powder. So you add liquid soap and some solid soap. You need to mix that. So that's a unit operation. You need to take the wet powder to a tower where you need to dry it. Then you want to run it on a conveyor belt. You want to add some perfume so that it smells nice. And then eventually it needs to go into a bag, and it all needs to be more or less the same weight. We don't want we want the powder to be nice and running. We don't want lumps in it. So that's what's done over here. So again, all of these steps are unit operations. And then the last one, even if you make marshmallows, and so every time you're now going to make something in the kitchen, even if it's a cake, you will think unit operations, because adding sugar, then adding syrup, heating that, mixing it, then pushing it into little shapes, cutting it to the right size, all of that is unit operation. So even in making sweets, we use unit operations. And so if you think about those unit operations as those building blocks, then it should be clear that chemical engineering goes across basically anything you can think of. So a short example of how we make food, water treatment, making pharmaceuticals, energy production, cosmetic chemicals, special materials, clothing, anything you can think of where we need to go from one product to another one while using solid handling, liquids, pumping, mixing, whatever you can think of. That's chemical engineering. So we're involved in all of these. So you can get into very different industries as a chemical engineer. And you might think, but all of this is already existing. So what can I add? And so you need to realize that all those processes we can keep on improving them, but we also sometimes need new processes. For example, if you now think about the current COVID crisis, so we've got biochemists and virologists very busy designing new vaccines, but at some point we're going to have to make a couple of billion doses of those vaccines. And at that point, chemical engineers will have to get involved to actually make vaccines at a scale where we can distribute them around the world. So there you can see that the scientists design the compounds, but it's going to be the chemical engineers who will make sure that it can be made on a big scale. And in terms of, so that's when new processes comes in terms of improving processes. You might realize a lot of the current processes are not very sustainable. So we need to look at how we do things today, and that needs to be different in how we do things tomorrow. So we need to move to a new model where we're not just looking at making profit like what we had up until now, and so we weren't really looking after our environment. So a lot of the industry is polluted water, soil, and so that's changed. And so all the processes that are in place today need to be looked at through a different lens, where we look at making them more sustainable for everyone. And like we just said, they're all based on unit unit steps. So we need to, as chemical engineers, be involved in turning all those processes around. So there is a lot of work ahead of us. And then how do we do that at UCT? So we've got a body of staff of about 20 academics, from South Africa, but also from other places on the continent and around the world. And so they all come with international recognition. We keep our connections with industry very tight. So we've got an advisory board that works with us, where we've got top people from industry present. So they can come and tell us, this is how we see where the industry will go in the next 5 years, 10 years, so that we know how to change what we teach to you as students. So for example, the drive to sustainability, the drive to other skills than just technical skills, which I'll talk to in a bit. All of those things is pushed by what we hear from industry. So that whoever graduates with a degree from us, comes with a set of skills that's very relevant for what the industry needs today. So and we do that in very, very modern facilities. So we've got special teaching rooms that are set up for how we teach. So we do a lot of project work, and so you need big tables there to sit around with plugs to plug your laptops in, so that you can easily work together in a team, because a lot of the project work is done in teams. We've got a big computer lab for once you get into the older years to work with specialized software, and also our research laboratories are quite new. Our undergraduate program, so where all of you would end up in, is very importantly, it's accredited by what's called the Engineering Council of South Africa. And the Engineering Council of South Africa is signed up what's called the Washington Accord. And so that's an accord between a lot of countries around the world, which means that your degree is automatically valid in those countries. So you can go work almost everywhere around the world because of the accreditation. And as I said already, we do a lot of project work, and typically we do that in teams, because there's one thing to teach the theory, but the project makes it real. So it's a real application where you need to design a certain unit in a plant if it's in the younger years, and then a whole plant when you go to the older years. And so you get to do things very similar to what you would do as a professional. So we train you step by step onto that path of becoming a professional engineer. In the first year, we have a lot of tutors. So we use a ratio of 1 out of 15 students between tutors and students. And that's to make sure that especially in the first year, we get everybody into the right mode. It's a big step from high school to university, and so we use those tutors to make sure that sort of no one is left behind, and that we all get everybody, and that we know where everybody is in the class. And then what we add to that is a lot of additional support. So we have an extended degree program that runs over 5 years instead of 4. But even in the sort of standard 4-year program, we make sure there's a lot of support. So in first year, that's around extra support with physics. We've got a life coach that comes to do sessions in little groups, so to also get you used to life beyond just the studying. We have things that are called boot camps. So if we see that students struggle a bit during the term, We've got, it's almost like a vacation time support program. So then in the VAC, you can do some extra classes with the tutors so that we make sure that in the second semester everybody is at the same level. And especially the combination of the boot camps and we've got a mentor program as well. So the boot camps, the mentors, the life coaching, the high tutors, we've really seen the success of that in our throughput rate. So more or less, if 120 students start a degree every year, 100 of those graduate, and so that's a success rate of over 80%. Of that 80%, there's at least 70 to 75% who graduate in minimum time. So which means in the 4 years in the mainstream program, or the 5 years in the support program. And that's quite unique in South Africa. We've got, as far as I know, by far one of the highest success rates in any program in the country. Because we feel and I'll get to that in the end, but our entry requirements are very high, and so we feel that everybody who walks through that door because you all deserve to walk through that door, and so it's then our task to make sure that we get you towards graduation. And then the last thing is and this is something we get as feedback from our industry partners, is that our graduates are very well rounded, and you'll see in a bit where that comes in. So to give you some idea of how we build up the degree, so the green boxes are actual sort of engineering fundamentals input. The brownish color is sort of maths and a bit of science, and then here you see more sciences, and in the final year there's a big design project and a big research project. And so how that all fits together is that we first, remember in the beginning we said you need to understand the science behind what you're handling. So that's what we do in the first and the second year, is making sure that we've got that foundation right. And then we apply that into our unit operation. So once you understand the science, the physics behind what you're dealing with, you can actually start handling it. Then you can know how to pump things, how to heat things up, how to mix it. And so that's a big focus in second and third year. And then once we move to the second half of third year and final year, we actually take all those unit operations and now we put them together just like a puzzle or a big set of playing blocks into an actual full process or a full plant. But not everything, and so that's sort of the like stepwise thing, year by year. But there's also themes that run throughout the whole degree. So I've already mentioned we do a lot of project work. All that project work is done in teams, both on the projects and on your practicals. We will ask you to make posters, to do oral presentations, to write reports. So you learn to communicate about your work, which is in industry is very important. If you've got a new idea, if you've got a new concept, you need to be able to go and communicate about it. Otherwise, nobody will ever hear about it, and nobody will ever know that you had that brilliant idea. I already mentioned at the beginning, we want to work in healthy environments, in safe environments. Things need to be economically viable, but it also needs to, and this comes back to the sustainability thing, needs to be good for the environment and needs to be good for the people who are affected by your process. So either the people who live around your plant, but also your employees, the people who buy your product, or receive your water that you clean, and things like that. And then the last thing is that all of this are complex problems where you need to do complex calculations. So we need some computing skills to solve that. And to now link back to what I said about a well-rounded graduate. So if you think about what you actually learn by doing project work, that's around complex problems. You need to be creative. You need to make decisions. You know, you can't. There's no right or wrong answer sometimes. So you need to make a decision on how you're going to do something. In teamwork, you need to learn how to work together with people you don't really know that well. You get to learn. You get to know each other as you move through the degree, but sometimes you don't know everyone in your class if you're there with more than 100 people. You need to negotiate stuff. You know, sometimes you want to do something that somebody else wants to do. You need to show empathy. If you think here about these things, about environment and social impact, you know, that's about critical thinking. That's about sustainability. And if you now think about all those skills, and then you look at what was published by the World Economic Forum last year around what are the skills for the fourth industrial revolution. So the skills you need now and you know for the years to come. That is complex problem solving, critical thinking, creativity. So all of those that I had on the previous slide, which we so we teach the science and we teach the unit operations. That's what we sort of call the technical skills. But in the way we teach it, through the projects and the teamwork and the other strands we have, we also teach you a set of skills that are relevant across the whole of society. So a lot of our graduates don't end up anymore in the typical industries like Sasol or Eskom. They work in banks, they work in consultancy, and they get there because of these skills. And so that's what I meant when I said well-rounded graduates. This is by far one of the most versatile degrees to get anywhere in industry, and so these skills can help you with that. This is very quickly, but you know that already. As I said, our entry requirements are fairly high, so it's 80% for math, 70 for science, and then if you add up your these scores and your best 3 subjects, you're guaranteed entry if you've got score 510. If it's weighted with a disadvantage score, if you go over 480, and it says likely, but it's very likely that you get in. And then there's a redress category where that number is at 420. So as I said earlier, we know that that's very high, but we then also do our very best to make sure that we support you all the way through till graduation. So that's all from me. I think Bridget will now alert me to some questions that have been posed in the chat room. I'll try to answer as much as I can right now. If not, like I said, we will put answers to you that we type up afterwards. So Bridget, if there are any questions, please. The first question I've got here, and that's probably one so Celeste is also online, who's from our admissions of our faculty office. So are there still spaces in chemical engineering for international students who haven't gotten an offer? Celeste, if I say something wrong, you can intervene, but as far as I know, there are. You just need to meet the entry requirements as they are listed on the faculty website. We can share that link in the chat box if you want. So there's another question around so if you're an international student with no background in chemistry, you know, can you be accepted? So we do require. So for South African students, we require that you've got physical sciences, which combines physics and chemistry. For international students, I mean, if it depends what country you come from, but if you've done the Cambridge system, then you need to have done both the physics and chemistry as an entry requirement. Not all till A levels. It can be up to the AS level, but you need to have done them both up until the AS level. So because I mean, the first year chemistry that you get, goes back a bit to high school, but you need some background. So the other question is, once one enrolls in the chemical engineering course, is there a certain level of progress that one needs to maintain in order to remain on track for the 4 years? Yes, there is. So actually, I'll come back to this slide, but basically, especially these first 3 years, so you can't progress to second year if you haven't. I mean, so there's some minimum requirements on these as well. So you can carry one of, not chemistry, but stats and maths. If you fail that in first year, one of them, it can be carried to second year. The chemical engineering one, you can't. So that's a big full year course. You need to pass that plus enough of the others to then move to second year. Same thing here. You need to pass this to move to third year, and so forth. So there is a minimum amount of credits. Firstly, just to progress, but also to stay in that trajectory of the chemical engineering courses, because they build on each other. So there's a question about how much is needed for English. As far as I know, there's no real minimum score on that. But so what we do is we add up your English, your maths, your physics, and then your 3 other subjects. So if you're not scoring well in English, you need to score really high in all of the others, because it does get added into the average. So it's okay if your other courses or subjects at high school are higher than English, but if you work that out, you'll see that you need to score in the high 70s or thereabouts to still make those cutoff scores. So there's no minimum, but because of the total score we require, the English needs to be good enough. And then the last, I think we probably have time for one more question. There is a question on the difference between chemical engineering and chemical biology. So there is quite a big difference between the two. So chemical biology, which probably is related to biochemistry, that is more of a science degree. So where you would look really into the nitty-gritty of how molecules work. Firstly, how they chemically are put together, so which atoms fit together, and then how that molecule works biologically. So if if it's used as a drug, or if somebody takes it in, or if it goes onto a plant, what happens to it? And so but that's, you look at that from a science point of view. What chemical engineering adds to that is how do you make it on a larger scale? What is required to actually make this as a product? So that's the difference between the two. Is where in the biochemistry you would look at understanding the science of the chemicals you're working with on a biological level. Then in chemical engineering, you would look at how do I make it, and what are the consequences if we make that on a large scale. And then there's a question, is it possible to major in finance and in chemical engineering? Not at the same time, but we have quite a few of our students who so there's a few elective courses you can take while you're studying. Typically, and a lot of our students take an economical subject as a free elective. But we've got quite a few students who then, with their broad skills that they have, go and do a master's or a postgraduate degree in financial management. And what is attractive to the finance sector is the fact that our students can handle very complex data and a lot of that, and you can code. And you can work well with Excel, which is all skills that are very important for finance. So you can't do them at the same time, but I've seen quite a few students do postgrads in a more economical type degree afterwards. Are there internships apart? So we do have a requirement that each student does 4 weeks of what we call workplace experience, and so that's something you arrange on your own. In second year, we do take, and that was before Corona, so I don't know how the thing will look like afterwards, but we do take all our students on a 1 week plant visit. So we split the class up in different groups, and then everybody goes to a certain plant in their group, and you spend a week on the plant doing a little project there. But that's 1 week, but then in further on, the 4-week one, you required to arrange yourself. The question is around international students, and how easy or difficult that is. So there is a preference typically from South African companies to give those internships to South African students. But a lot of our international students find work placements in the country they come from. So because indeed, it's not that straightforward, also legally for South African companies to offer internships to non-South African students. And then question 8 is around the science electives. And so that's around the way chemical engineering has evolved over the years. So we used to have every student doing chemistry in first year and second year, but we've seen that the industry has changed from to the only chemistry to also more minerals processing, biotechnology. And so at the beginning of first year, actually, you can choose to still do a second year chemistry, but there's also an option to at second year level do a biotechnology combination or a mineralogy combination. So we don't let everybody from second year onwards just do chemistry anymore. We give a bit of choice so that you can structure your degree according to the kind of preference that you have. I'll keep answering questions until the production team tells me that it's time to wrap up. So production team, if it's fine for me to continue, I will. Otherwise, just let me know. Question 9. What is the latest date for me to receive acceptance for the program if I'm an international student? I wouldn't know that answer, but I think that's one that we can ask the faculty and then put that in the write-up that we will post afterwards. I'm going to ask Bridget, are there more questions coming through? Otherwise, I think we'll round off. Okay, so I've got a question for the latest date of acceptance. Yes, so we usually, international students get told mid-November, because you obviously need to have time to apply for your visa, so for your study permit. So yeah, so if you haven't heard yet, as an international student, by mid-November, things would come through. Okay, so if there's no more questions, I'll first thank all of you to be online and to come to this virtual open day. It was my first one, probably from you as well. And I'm really looking forward to see you all, not through a computer, but in some form next year on campus. We'll probably go into some blended mode, but at least you'll be a lot closer to us than where you are now. Oh, I see another question coming through. So after you graduate from chemical engineering, what career paths are available to you, and are there enough vacancies in South Africa? So as I said earlier, because of the fairly versatile degree, if you're open enough to different options, there's quite a few. My graduates still find work quite easily. Not anymore in the traditional sectors, so places like Sasol, Eskom, a lot of the mining companies are not doing that well at the moment. But where we see a lot of our students go to is, like I said, they go into consultancy, a lot of them into more sort of renewable energy consultancy. There's a lot of independent power producers that are going to come online or come into the country. Chemical engineers can work there. The finance sector remains a fairly big taker of our graduates. So the career paths are very, very wide. I think on our Facebook page or on our Instagram page, there is a graph actually where all our graduates end up. And the finance sector and consultancy sector have really sort of almost become one of the bigger employers more recently. So at the moment, it's still a very good career path, both in South Africa or in other places around the world. So I think the other questions we will, if more come through, we will answer that and probably post on Instagram, Facebook, our webpage, for you to and send it to you if we've got all the details. So again, thank you so much for being here, and really looking forward to seeing all of you on campus in 2021. And if there's any more questions that you have, please email us or find us on our social media channels, and then we'll do our best to answer your questions. And so I'll hand back over to our production team right now.